Simultaneity. This is what we're going to think about now, and I'm going to talk you through some of the slides and then show you a little animation that will hopefully help explain the idea. So simultaneity is really part of special relativity, or a consequence of the two main points of special relativity. Firstly, that light travels at the same speed, all observers, and secondly, that there is no preferred reference frame. These are the two key ideas that are challenged by this concept. And the concept is really, can one event happen and two observers see that event, two observers in different reference frames, and can they agree that the event happened at the same time or was a simultaneous event and occurred at one time? And the answer is no, not necessarily. So in thinking about this, we go back to the idea of a thought experiment. And in this particular case, we have a train carriage, and this is a picture of a train carriage here. And there's two observers, O dash, or the observer on the train, and O, the observer, the stationary observer, relative stationary observer. And what we need to think about is an event where light is moving or light is travelling. And a good example of this would be if two lightning bolts simultaneously struck both ends of the carriage. And then we're going to think about what this observer would see and what this observer would see in terms of when the light hit them. Okay, so this is the idea. Okay, let's look at this first situation. Let's think about the observer who is stationary, and we've got these little wheelie lines here representing the path of light coming from point A and point B. So if we go back to this idea, A dash and B dash, and A and B, that's the points where the lightning struck, and then lightning will be travelling in a straight line to both of the observer's eyes. So let's think about this observer here, standing stationary. So she sees light travelling from point A and light travelling from point B, and she's equidistant from both points. So she will observe that the light will reach both of her retinas at the same time, and therefore she will state that the lightning struck the front and the end of the carriage at the same time, because light travels at the same speed in this direction and in this direction, and so therefore if it's covering the same distance, it will take the same time, and she will state in her frame of reference that the lightning bolts both occurred at the same time. So, and that's true and right for her. Now we need to think about the observer who is actually travelling. Okay, so in this situation, we're going to think about this observer, O dash, the observer who's on the moving cart, and let's think about what they're going to observe. So originally, the cart was over here, and the light started travelling at this point here, and also at this point here, B. But what has happened is, because there is also a velocity in this direction of the cart, this observer is going to observe the light from this point B hitting his retina, this side first compared to this side. The light is sort of trailing behind, trying to catch up, and this light has got an additional velocity vector in that direction. So he's going to observe on the cart that the lightning struck the front of the carriage before the lightning struck the back of the carriage. In other words, for the same incident, two observers can make a different statement about which event happened first. So you have to think about that. For one incidence of an event, two observers in different frames of reference can disagree whether it was a simultaneous event, happened at the same time, or whether, from their perspective, in their reference frame, there was an event that happened first. And this is a challenge for us to consider, but this scenario is the best way of thinking about it. And the key to understanding this is that there is no preferred reference frame. Both of these observers are true and their observations are accurate. So what I'm going to do is show you a little image of things moving to help see if that makes it clear. Okay, in this little GIF we have almost like a reverse of the situation. So this is relatively stationary, and in this instance the observer is sliding along. That's okay, the same principle. So we have this light source A and B, someone standing in the middle equidistant, and they would observe that the two sources of light began at the same time. So that's from their perspective. So you can see that the light is kind of like the wiggly line travelling towards Einstein in the middle. So that's the first one. Okay, here's another way of thinking about the second option. In order for a moving observer to agree that both events happen at the same time, or for the light to reach them at the same time, the events would have to happen at a different time. So in this case, if light is travelling from both source A and source B, it would have to start at A before it started at B to reach the observer at the same time. So for this observer and for that observer to both agree that the light sources originated at the same, or got to them at the same time, one observer would have to say that one source of light began first. And so both of them are correct in their reference frame, but they cannot agree that the event happened at the same time.